All these changes in state of matter can be put on one place, and that is the heating curve. So on the heating curve, we are slowly, gradually heating any solid material, and we are observing that it is converting from solid to liquid and then liquid to gas. This is one of the graphical way to explain it. On y-axis there is temperature, on x-axis there is time, and on this graphical way we can put the data and we can put all the information. So this is one of the very powerful way to express your data and express your information. So by just one glance you can see all changes that are taking place. So here we are starting from a point and we are heating, so gradually it is rising up. So at A we have ice and we are heating it. It is gaining heat energy, and with the gain in heat energy the temperature is increasing gradually and slowly, and at the point B ice has started to convert itself into liquid water, and that temperature is called the melting point. So melting point is that temperature at which ice solid is converting into liquid water, and that is 0 degrees centigrade. But there is one of the very amazing point that from B to C, the time is passing on, but the temperature remains same. We are heating it. We are providing heat to it. But why the temperature remains the same? When ice is converting into liquid water, the particles of ice, they are closely packed together, and there is a force of attraction between them. So the solid particles are more closely packed and they have the forces of attraction, and these forces of attraction must be broken. So during that time span, all the heat energy is basically utilized in breaking down the forces of attraction existing between the particles of solid. When all the particles of solids have been converted into liquid, then the temperature will start rising, and the thermometer can sense it. So between B to C, this is the latent heat. This heat cannot be judged, cannot be sensed by the thermometer. And when all the ice has been converted into liquid water, then temperature is again rising and can be sensed by the thermometer. So from A to B, it is all ice. It is gaining heat. From B to C, ice is converting into liquid water, and between B to C, ice and liquid water both are coexisting. From C to D, basically it is all liquid water. So liquid water is gaining heat energy, and at the point D, the temperature has reached 100 degrees centigrade, and at this temperature water started to boil and is converted into steam. So between D to E, it is the liquid water which is converting into steam. The liquid water is converting into steam, and the steam and liquid water both coexist between D and E. And again you can observe that between D to E, the heating is providing, but the temperature is not increasing. Again, it is where the change in state of matter take place, because in liquid water there are some forces of attraction, and these forces of attraction are basically broken down. So here between D to E, all the heat energy is basically is breaking down the forces of attraction existing in the water. And till the point E, all the water has been converted into steam, and from E to F there is all steam, all gas, and that is gaining heat energy, and it can be sensed by the thermometer. So from point A to B, it is all ice. From point B to C, ice is melting, and ice and water, they coexist. From point C to D, it is all ice has been converted into liquid water, and from point D to E, water boiling and liquid water and steam both coexist. And then point E to F, it is all steam. So remember, when there is a change in state of matter, temperature will remain at a fixed point. Actually, where the heat is going, that is an exam question. Basically, the heat is utilizing in breaking down the forces of attraction existing there and all the heat energy is basically utilizing in bringing a change in one state of matter into another state of matter and breaking down the forces of attraction in the state of matter.